with this music? My goodness. Let's bring it back in. Welcome on in, everybody. I realized that I was studying by myself on Unlisted for 8 minutes, but I'm glad you're all here now. So, funnel into the auditorium. I'm just doing 60 minutes study session. I'm continuing on where I left off over the weekend, and I'm going to continue to unroll these kind of live study sessions. You'll see the problem I'm working on here. I may not move it too much because I'm dropping my pen on the ground. Doing hand counts down in front of me here. When I have a non-potato computer anymore, I'll be able to do like I do in my videos and actually do live calculations on the screen that you can see in front of you. So I tried setting that up over the weekend. Didn't work out great. I literally couldn't stream. My computer just wasn't capable of doing it. And so for now, we're just going to do this little study vibe session more and more and more for all of you and myself to better ourselves. So jump on in, even if you're not doing engineering. I'm glad you're all here. Do that YouTube thing. Leave a like if you're feeling it. And before you go, if you haven't yet, subscribe. All right, but I'm getting back into the calcs. So I'll see you later. Uh-oh. Music too loud. Okay. Let's see. Hopefully that's a little bit better. How's that, Hugh? A little bit better? If you're walking through this problem with me, I will make some notes here. I guess I can't, I don't have my pen of learning. I just got a mouse right now because I got no touch screen with what you're looking at. But this is the SEAOC design manual, and it's a 2012 version. So this has out-of-date codes that you need to be careful for. All of the processes, for the most part, are still the same. But you'll notice some stuff through here, and I was just scratching my head here. This one right here, for your vertical component of your seismic demand, in the 716, it's 0.2 per chapter 12 now. So it looks like they increased that from 0.14 back in the day. So an additional thing that I'm doing while I go through this design example is I'm also applying more real-world information that I believe is needed if you were designing for real. So previously, I just designed the hold down, at least the forces that are required to design for. But next, the step would be, and then it would move into your end post design for compression and all that kind of stuff. But it kind of skipped the step of saying, okay, well, you have your force for the hold down, but now you actually need to determine and spec a hold down. So I pulled out kind of in between here, so my Simpson manual, and I'm going to specify a hold down based on the capacity, or based on the demand that I have calculated. And so I just went through and determined I'm going to use an HTT5, and one, because it's got enough capacity, but then the reason why I'm adding this to my studies is that it's important for then the next phase. So this end post design, you know, they talk about it a little bit right here. So providing double 2x4, blah blah blah. They tell you like we're doing this, which is a pretty common end post for compression in a shear wall. But there's also minimum wood member sizes, depending on the type of hold down that you use, that are spec'd in the design manual for the Simpson products. And so that HTT5 that I said, okay, it has enough strength, you need to make sure that you are accounting for all of the conditions that are required in order for that product to reach that strength. It's important. You can't just look at the value and say I'm good and move on. If your condition can't accommodate it, then you don't get to use that strength, and you don't get to use that product. So it's those little things that make you better as an engineer, instead of just looking straight up at numbers and calling it good. But with our HTT5 hold down, we can use a 3x3.5 post for our condition. So two 2x4s stacked together is adequate. So bang, we're good to go, because that is literally what two 2x4s together are. Fabian, thanks for coming in. Hey, that's really great to hear. I'm like, that's always the best news, right? And since starting this channel and studying with all of you and helping myself and helping all of you, hearing that just means so much more. So congratulations, huge thumbs up. Thanks for letting me know. Another thing to point out is they have visually graded and they have select structural for end posts. That's pretty high quality lumber, I would say. Usually you see number 2s or better kind of spec'd out. So that's another thing where, wow, we get to use some stronger design values. But I'm gonna roll with that, so that means I gotta grab the NDS. Thanks everybody for stopping in, leaving a quick like. I know it's small, but I appreciate it tremendously. It means a lot to me, and it helps the channel grow. So that means it gets in front of more people, more eyes, more people with questions who just need some answers or just needs a nice place to study. So appreciate it. Welcome in, everybody. Can't believe we have double-digit people coming in. This is great. All you night owls out there, I love it. going with a little more ambient background music. Let me know if that's not your jam. I'd be happy to switch it up on the fly anytime. Yep, I'd love to share the notes. Soon, you'll be seeing all my hand calcs as I'm doing them with you when I can finally get my hands on a computer that is capable of sending all of that info and streaming it live. I just don't have a computer that's good enough right now. I can record it and make videos like you see all my other videos, but so far doing it live, I've found that my computer just can't keep up. It keeps crashing the stream when I try. Otherwise, I would share my notes with you. I'm just refreshing myself super in depth on wood shear wall design, and then from there I'm going to be taking it a step further and designing for, so I'm doing a solid shear wall right now, then I'll be doing segmented shear walls, and I'll be doing perforated shear walls, and force transfer around openings, and really trying to understand everything about those, so that I can potentially in the future utilize them if a situation arises where you need to. Most of the time you try to avoid them if you can, makes it easier, but I want to have that ability in my back pocket, so that's what I'm doing right now. Later. Yep, there it is. Cool. Alan, thanks for jumping in. I haven't done a lot of these, but this is something that I will be doing more and more of, as it's important for me to sit down and be studying as well outside of work, as I slowly pursue taking my SE exam sometime down the road here. So I'm looking to start doing these once or twice a week, maybe more if time allows, but just little study sessions here and there, and then maybe a bigger chunk one sometimes to really focus in on a new topic that I'm hazy about. And then if you're new here, as it gets better, I'm going to be expanding upon this concept. With computer upgrades, I'll actually be doing my notes, my calculations live in front of everyone, and you'll be able to follow along with me, and see everything that I'm doing. You know, I'm doing it right now on paper in front of me for myself, and then the problem is right here. But that's not too helpful for all of you if you're going faster than my slow self or wanting to learn something else. But slowly but surely, these study sessions are going to get more involved, more hands-on with everybody. Bow, if I'm saying that right, hopefully. Yes, I am studying for my SE. It's down the road. It's not right around the corner. Maybe I'm gonna get aggressive, and maybe I'll take gravity or lateral separately, maybe this coming October. But besides that, it may be like a year down the road. But yes, I am in the pursuit of that. This is all compression. So I was just running calcs on tension. Oh, that was a perfect line. Let's go. Nice. Hey, I'm glad you're here. Get after it, my man. I love that. I love to hear that. I'm not currently taking any courses. I'm kind of taking it at my own speed right now. I didn't take any courses for my PE studies. A lot of my friends did, though, and they absolutely loved them. I have some connections with some coworkers from the past who actually taught SE prep courses, and they gave me some materials, and maybe I'll slip that into all of you to get a hold of. And I don't know, as I talk more with my affiliate with School of PE, I may be able to jump into one of their classes and see what it's all about and let all of you know. So I think I'm going to utilize as many resources as I can for this one. This is the biggest one, but doesn't mean that it's bigger than any one of yours that you're taking, even if it's a high school math test, you know? We all got that little bit of anxiety about test taking, I think, even if we are great at taking tests. I know I never was. But over the years, I feel like I've gotten more confidence, and that going through kind of a mindset shift rather than just becoming smarter, because I don't think I ever became smarter by any means. I think I just got more excited about wanting to study for myself and to learn more things for myself. That kind of changed my perspective and made it easier to grasp knowledge and concepts. Totally off the rails. Sorry about that. Let's jump right back in. Because I'm getting that our post in tension, combined tension and bending, is not working. So let's see what the heck's going on here. Alright, I used the 3-inch eccentricity as well. And what I did was I took our post, which is 2 2x4s. So actually it's like that, which equates to 3 inches because it's 1.5 inches each. Then you have your hold down device with your anchor. Here's your sill plate. And then your concrete below. But you do technically, this is your center line of your post, and you have this offset to your anchor, which is now some sort of eccentricity. So I took that as 1.5 inches because it's one post, one traditional 2x stud, and then I set another 1.5 inches to the actual bolt or anchor, which gives us a total eccentricity of 3 inches. And then you multiply that eccentricity by your tension reaction, and we did ASD, so T-rec, which gives you your bending moment in your stud. So you never want to just consider it as purely a tension or compression element at the end of your shear walls. There is those little eccentricities as you zoom in on your design. You got all these little tiny things that start to happen, and you want to make sure that you're clear about. Oh, do I know how to erase? It's okay. Oh, let's lasso it. How about that? Yeah, there we go. Hey, Bow, if you don't step back in, you don't, you're not studying with us, good luck. All of us are rooting for you. And make sure to smash that like button before you leave, because then you'll definitely pass. Nah, I'm just kidding. Thanks for stopping in. Alright, I'm over the hour mark, and I promised that I would do some stretching tonight, so I'm going to wrap this up here right after I just confirm this number. And then I'm out of here, gang. That's it for tonight. See, they jacked up because they're using a select structural. I'm using a number 2. They got 1500. I was only rocking 900, so that's why it works out for them. Here we go. Combined tension pending. Yeah. I'm getting 1.08 for my combined ratio. So, I mean, so what can we do, right? Okay. We got a problem here. Calc it out. I mean, in all honesty, the easiest thing for tonight, since I do want to wrap up here, is that instead of a number 2, we would spec number 1. Number 1 grade studs. Or not studs, but number 1 grade lumber, especially for our end posts. That would bump up our specimen properties and our design properties, and that would decrease our ratios of our demand to capacity. That would get us under that 1%, and there you go. You're off to the races. You're good to go. This one's weird also. So you have to check these 2 equations. So this one here, and this is per the NDS. And they give this one, and they have this FB star, and they say all the factors that apply except for CL. And it's like, okay, that's great when we're looking at, dimensional lumber. But then the next equation that you also have to satisfy is this one, FB star star. And that is all of your adjustment factors except for CV. And you're looking at that table for dimensional lumber. There is no CV factor for dimensional lumber. It's for glue lambs and other stuff. So to me, I don't even know why you would even check. I took that as, okay, that equation doesn't apply to us because we have conventional lumber, so we don't have CV, so that's not our case. But they're still checking it here, and I mean, they're showing that it's actually even less of an issue. It's not controlling at all, 0.38 versus 0.59. So I guess my check, it was valid that I didn't even have to check it, but I'm surprised that you do have to check it, because again, it doesn't change anything. And if that's the equation you're checking, then it only makes it even easier. So I don't know, something kind of interesting. I'm just talking out loud too into the YouTube universe. All right, then we're getting to shear wall deflection. I got to do compression next time. Okay, that was a little slow tonight, but again, I'm really getting into it. Before I go, because I'm more so mandated by YouTube and the algorithm and everything in between, I'm going to send you off with this. Before you go, before you click off, give it a like. Even if you're only here for 5 seconds, you are still in here, and I appreciate it. If you want to be part of Team Kestävä and join thousands upon thousands of other engineers from around the world bettering themselves, subscribe down below. We're working on the auditorium. It's under construction right now. Jose is actually an intern. He's a field engineer on the project. We are expanding like no other, brand new, state-of-the-art, because we got almost 6,000 of you here, and there's going to be so many more, especially if you decide to subscribe down below. Kevin, you're going to be my last comment. When's your next study sesh? Man, I'm thinking doing, somebody else asked that, like 2 or 3 of these a week, man. I want to start getting in. They don't need to be particularly long, and just getting into it and not necessarily prepping problems for videos, but to really get into those nooks and crannies of areas that I don't fully comprehend, because I don't know it all, right? So yeah, like 2, maybe 3 a week. Pop in, pop out. I'll hopefully get a more consistent schedule so that you guys can be prepared and jump on it as well. But all right, this is Rich with Team Kestävä. Appreciate every one of you. Keep on learning, keep on growing, I'll see you in the auditorium next time. Later.